This video is going to be about the engineering design process, sometimes referred to as the EDP for short. It is a systematic approach to solving a problem. It is something that reflects what is used in the industry by engineers and other people that are professional problem solvers. And our engineering design process looks like this. It has 12 steps, with the first step being defining the problem, because you have to know the problem that you're trying to solve. And then 2 through 12 kind of broken up into 4 phases that will help guide you to brainstorm possible solutions, refine those solutions, pick the best solution, and then make a prototype of that solution and communicate those results. So it's a very regimented way of looking at a problem and finding a way to solve it. So this slide demonstrates the 4 phases. Now, each of the 4 phases breaks up the steps that are very similar to each other. So phase 1 is all about the solutions, coming up with as many different solutions as you can, exploring those solutions, and then establishing criteria about the problem itself and or the solutions to help you start figuring out which one is the best. Phase 2 is all about considering the alternative solutions, selecting one, and starting to develop that best solution that you have. Phase 3 is all about making a prototype, testing the prototype, and then redesigning that prototype as necessary to make it as good as possible. Phase 4, which is only 2 steps, is all about creating a product to communicate your design. Now, a lot of times that's going to be in the form of a presentation. It could be in the form of a, advertisement, but something to communicate the features and benefits of this product that you just created through this process. Each of these slides has a little bit more information, a little bit more of a description of what each of the steps consists of. So I'm not going to go through these, but I encourage you to. And when you get to the flow chart, you will see that there is also another, a little bit more information on each step. Let's look at one example right now. So the first example I like to talk about is the cabinets in front of my class have these little tiny handles that make it really hard to pull because it's a heavy drawer. So one question I posed to my students last year is to create a handle for these classes. That was the problem I stated, was I need better handles that are more comfortable to pull, that allow more pulling power for these drawers. So they went through the problem solving process, the 12 steps, to create one. Here's some examples of the steps 2, 3, and 4, or the first phase. So they brainstormed ideas, they researched some of the solutions. I gave them some additional constraints on some of the dimensions. They looked at the different solutions. They even looked at that store-bought versus made solutions. They used an analytical method to select the best solution. And then they got to the prototyping phase where they actually used CAD to design and 3D printers to make handles. They tested them. A lot of students had to go back and remake them. And they also provided a presentation to communicate the handle they had designed and its features and benefits. And then lastly, these are a few of the solutions that students produce. Now, they're all very different, and that is completely natural within the engineering design process, but they were all functional. They all did the job, and they were all fulfilled the requirements and criteria that I gave them. So this is just one example, and it's, this is not very formal. This is something that was done totally in class with class resources, but it's a really good example of why we use the engineering design process. And a lot of times we use it in a more informal manner too.